Our next speaker, Dr. Pallab Sarker, who's been working with a suite of different algae on aqua feeds with tilapia and some other species, here from Dartmouth, and I guess getting ready to become a Californian. Hi, Pallab.
Hi, everybody. First of all, I would like to thank you very much to F3 team, just last minute, to just giving me this opportunity to speak today, and absolutely I am grateful to you, and thank you very much again. And today, actually, I am Pallab Sarker from Dartmouth College. As Kevin mentioned, I am moving to University of California, Santa Cruz in June as research associate professor. And my research interests involve shifting aquaculture to sustainability by redesigning ingredient composition of aquaculture feed, because they have life cycle environmental effect on input sourcing and output like eutrophication, emissions, and etc. So my research focus on this both input sourcing and also output emissions. So today I am happy to talk about our, which one is actually? So I'm really excited to talk about our invention of F3 tilapia feed, and actually the story that how we make this happen. And actually I worked basically with this aquaculture and aqua feed sector since many years, more than 20 years, because I born and grew up in Bangladesh, and I had the tremendous opportunity to work with many species of carp and shrimp, especially in coastal region of our country, and we are a great exporter in US and EU. And after that I moved to Japan, and I conducted several experiments with yellowtail and Japanese flounder to make a sustainable aquaculture feed, mainly low pollution feed to reduce eutrophication emissions. And so today I'm, and then in Canada I spent actually 4 years, and I have conducted several experiments with trout for sustainable aquaculture feed using microalgae and other stuffs. And now, and still this line of research is still I'm doing. And now I'm really fascinated with tilapia. It's amazing species actually, and globally second most farm fish by volume. And this is a really wonderful species that feed low in food chain and can be evolved to eat microalgae. So this is really great. And tilapia would be two fastest growing aquaculture products in the next decade. And the US and global consumer demands are increasing, and also what is the significant challenge is facing this tilapia industry is public perception, and also some research showed that depression of omega-6, imbalance omega-6, omega-3, whether we eat tilapia or what can. It's $1 million questions from the consumer point of view. So we would like to address these issues. And we have conducted series of experiment with stepwise experiment. First, we have conducted digestibility experiment, and we have found Syzygium, marine Syzygium is one of the best source for fish oil replacement, and we detected the highest digestibility of lipid, fatty acid, and phosphorus. And based on this digestibility data, digestible nutrient basis, we formulated diet to replace fish oil in tilapia feed. And we found significantly improved weight gain, feed conversion, and protein efficiency ratio when we replace 100% fish oil in tilapia feed. And that is tremendous that tilapia can be deposited highest amount of DHA if we compare to fish fed on reference diet. So this is really cool. And then next question, we asked ourselves whether we can replace fish meal by any source of microalgae or co-product. And then we contacted Qualitas Health, and they actually they are producing, as you know, because the last previous our Sunil actually told about the Qualitas Health, and they are commercially producing nanochloropsis oculata for nutraceuticals purpose. So the leftover biomass after oil extraction is co-product. So they actually donated us the bulk amount of co-product for our experiment. And again, we conducted digestibility experiment, and we found actually protein digestibility is lower than whole cells. And also methionine, even though the protein content is higher in co-product, like almost 50%, and then methionine also, it lowered digestibility we found, but lysine was not. And based on this digestibility data, again, digestible nutrient basis, content basis, we formulated a diet to replace fish meal using nanochloropsis co-product. And we detected actually like excellent growth in a diet replacing 33% fish meal. And what is the problem? Why we could not replace higher level of fish meal, and why methionine and protein digestibility is depressed? And we found anti-nutrients content in nanochloropsis co-product, and now we are treating to improve this co-product by using specific targeted enzymes, and so on and so forth. And our fish free, based on this digestibility information, we actually we drew upon these results to formulate, to develop fish free feed, and we found significantly better growth and protein efficiency ratio and survival. And and it is really tremendous and amazing combinations, and it's a game-changing formulations. And I think it's a tremendous opportunity as market potential. And I think niche market can be developed by using these formulations. And aquaculture feed industry could explore this opportunity to explore these game-changing formulations to aquaculturists to cater to the willing to pay premium price on this health enhanced product actually. And also this will help a lot to redefine to redefine that the public confidence, to re-establish public confidence that health benefit of eating tilapia, and it's not erodes the health benefit, it helps health benefits using these combinations. But in order for nutritionally enhanced tilapia to succeed in the market, we actually R&D need to find the way to cut down the cost of the microalgae, because if we see the feed conversion, so fish-free feed is 1.4 and versus 1.6 reference feed. So there is still room to improve fish feed conversion by improving digestibility. But if we based on these results to see the cost, the feed economic conversion ratio, so fish-free feed costs 1.9 versus $1.65 reference diet. So there is still, and I think R&D efforts and also multi-product, our collaborator Selena Martins just described, and we are collaborating with Selena also to see that multi-product food, feed, ingredients, nutraceuticals, and inks can play a pivotal role to cost down of microalgae. And we also we are trying our nutritional input to improve the digestibility and so on and so forth by treating enzyme and other process. And here is very nutshell. In a nutshell, I'm telling about our story like salmonid, like trout. So previously we found combining Syzygium and canola like showed as substantial fish oil substitute in trout. And recently we found isochrysis is the better candidate in terms of protein digestibility and all amino acid profile and fatty acid profile digestibility than nanochloropsis whole cells. And our F3 feed formulations combining nanochloropsis, Syzygium, and also isochrysis with canola showed little like minor but significant lower growth, mainly due to palatability issues. So now we're working hard. How can we improve the palatability issues using additive oil, using feeding stimulants and other things? And thank you very much. Thank you so much. Any questions, please? Just thank you, thank you, Selena. Thank you, Qualitas Health, for just continuing collaborating with us. And we explore more collaboration, and also we need research funding to continue.
Question? Yeah.
Please.
So regarding the digestibility of the whole cells versus the co-product, so my understanding is if you do some kind of a treatment, usually the digestibility increases. But in your case, you are saying there is some anti-nutritional factors that are introduced. Is it the chemical anti-nutritional factors, or so the only process I would assume is that you might have done a chemical treatment of the cells, right? So what are the anti-nutritional factors that you're talking about?
Mainly like trypsin inhibitor and fiber content also, and also non-starch polysaccharide that we found. And now we are treating with different enzymes, actually non-starch polysaccharide enzymes to improve digestibility of fiber and also protein, because lectin, pectin, and hemicellulose content also was higher in co-product, and we are trying to improve the digestibility. That means that will help also to grow, and also feed conversion ratio to improve with this approach, actually.
Okay, thank you.
Any other questions? I think everybody's ready for a break. All right. Thank you, Bob.
Thank you
Appreciate
so
it.
much. Thank you, Kevin.